Engineering is constantly evolving. New technologies emerge and reshape the way we design, build, and innovate. Today, we stand at the cusp of another technological revolution, one driven by artificial intelligence. By 2030, AI will be more than a buzzword. It will be an integral part of the engineering DNA. This isn't science fiction. We're already witnessing the early signs. AI-powered tools are assisting engineers in various sectors, from optimizing building designs to predicting equipment failures. The next decade will see this integration deepen and expand, leading us to an era of unprecedented efficiency, precision, and innovation. Imagine a world where bridges design themselves, buildings adapt to weather conditions in real time, and manufacturing defects are predicted before they even occur. This is the promise of AI in engineering, a future where human ingenuity is amplified by the power of intelligent machines. Join us as we delve into this exciting future, exploring how AI will redefine the very fabric of engineering by 2030. The impact of AI on engineering will be nothing short of transformative. By 2030, AI will permeate every stage of the engineering lifecycle, from the initial design phase to the operation and maintenance of complex systems. This shift will be driven by AI's ability to analyze vast datasets, identify patterns, and make predictions with a level of accuracy and speed that surpasses human capabilities. Imagine this. An architect wants to design an energy-efficient skyscraper. Traditionally, this would involve countless hours of calculations and simulations. With AI, however, the same task could be accomplished in a fraction of the time. AI algorithms can analyze weather patterns, building materials, and energy consumption data to generate optimized designs that minimize energy waste. But the impact of AI extends far beyond design. In manufacturing, AI-powered robots will work alongside human technicians, performing complex assembly tasks with precision and speed. In construction, AI algorithms will monitor structural health in real time, alerting engineers to potential issues before they escalate into costly problems. The key takeaway? AI won't replace engineers. Instead, it will empower them. By automating mundane tasks and providing intelligent insights, AI will free engineers to focus on what they do best, solving complex problems and pushing the boundaries of innovation. The numbers speak for themselves. The global AI market is on an exponential growth trajectory. By 2030, the market size is projected to reach a staggering $667.9 billion, growing at a compound annual growth rate of 24.4%. This surge in investment reflects the growing realization that AI is not just a technological advancement, but a fundamental economic driver. What's fueling this growth? Primarily, it's the increasing adoption of AI across various industries, including engineering. Businesses are recognizing the potential of AI to unlock new efficiencies, reduce costs, and create innovative products and services. But the economic impact extends beyond market size. AI is expected to add an estimated $4.4 trillion in annual value to the global economy. This value will be created through a combination of increased productivity, reduced costs, and the development of entirely new industries and business models. The message is clear. AI is not just a technological trend, it's an economic imperative. Those who embrace its potential will reap the rewards of a more efficient, innovative, and prosperous future. Imagine a world where the design process is no longer limited by human imagination or computational power. This is the promise of AI in engineering design and simulation. AI algorithms can analyze massive datasets of existing designs, material properties, and performance data to generate innovative solutions that would be impossible to conceive through traditional methods. Take, for instance, the aerospace industry. Designing an aircraft is a complex undertaking involving countless variables and trade-offs between weight, aerodynamics, and fuel efficiency. AI can streamline this process by rapidly generating and evaluating thousands of design iterations, identifying optimal solutions that meet specific performance criteria. But the benefits of AI in design go beyond just optimization. AI can also help engineers explore radical new concepts and push the boundaries of what's possible. Generative design, a nascent field within AI, allows engineers to specify design goals and constraints, and then let the AI algorithm explore a vast design space to generate novel and unexpected solutions. This transformative power of AI in design and simulation will lead to the development of lighter, stronger, and more efficient structures, vehicles, and machines, paving the way for a future where engineering marvels become the norm. Section 5. Manufacturing and Construction, Efficiency and Precision Redefined. Imagine a factory where robots work tirelessly alongside human technicians, performing intricate assembly tasks with speed and accuracy. Imagine a construction site where drones survey the progress in real time, alerting workers to potential safety hazards and ensuring that the project stays on schedule. This is the future of manufacturing and construction, powered by the intelligence of AI. In manufacturing, AI-powered robots will take on repetitive or hazardous tasks, freeing up human workers to focus on more complex and creative aspects of production. This collaboration between humans and robots will lead to increased efficiency, reduced error rates, and safer working environments. Meanwhile, in construction, AI will revolutionize project management and site safety. Drones equipped with AI-powered vision systems can monitor construction progress, identify potential hazards, and even perform inspections in hard-to-reach areas. This real-time data will enable project managers to make informed decisions, optimize resource allocation, and ensure worker safety. The integration of AI into manufacturing and construction will not only boost efficiency, but also improve the quality and durability of the structures we build. By analyzing data from sensors embedded in buildings and infrastructure, AI algorithms can detect structural anomalies at their earliest stages, preventing catastrophic failures and extending the lifespan of critical infrastructure. Section 6. Prompt Engineering, Guiding AI's Potential. As AI systems become increasingly sophisticated, so too does the need to effectively communicate with them. This is where prompt engineering comes in. Prompt engineering is the art and science of crafting precise instructions and inputs for AI models, enabling them to generate the desired outputs. Think of it like this. You wouldn't just ask a chef to make me food. You'd provide specific instructions about the dish you want, the ingredients you prefer, and the level of spice you enjoy. Similarly, prompt engineering involves providing AI models with clear and contextualized instructions to ensure that they understand the task at hand and produce accurate and relevant results. In the context of engineering, prompt engineering will be crucial for tasks such as generating design concepts, optimizing manufacturing processes, and analyzing complex data sets. Engineers will need to develop a deep understanding of how to effectively communicate with AI models using a combination of technical skills and domain expertise. The rise of prompt engineering highlights a crucial aspect of the AI revolution. It's not just about building smarter machines, but also about building more effective bridges between human intention and machine capability. As AI becomes more integrated into engineering workflows, the ability to effectively speak the language of AI will be a highly sought-after skill.